So today we're talking about angles and arcs within the circle, okay? And the first type of angle we want to talk about is a central angle. And I think this kind of goes with what the word says. It is an angle whose vertex is at the center, hence central angle, okay? Its sides are radii of the circle. So angle 1 is a central angle, okay? This right here is a central angle. Its vertex is at the center, and the sides of the angle are radii of the circle. Okay, so this right here is considered a central angle. If you were to add up all the central angles in a circle, none that overlap, it's always going to be equal to 360 degrees. Okay, so if I took the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3, it will equal 360 degrees. So looking at this example right here, okay, we have this angle AOE is X, AOB is 130, and then I have that little right angle symbol here, okay? So what's going to be true about all these added together? 3 equals 360, okay? So I've got X plus 130 plus 90 equals 360. So 130 plus 90 is what? 220? And then subtract 220 from both sides, and so X is 140 degrees. All right, here's another one. Okay, we want to find the measure of angle AOD, which is this little angle right here, okay, which means we need to find X. All right, what does this diameter AB do to the circle? It cuts it in half. So if all the way around is 360, what's this going to be right here? 180, right? So the diameter, is, kind of goes back to one of your pairs. So we have 25x plus 3x plus 2x equals 180, half the circle. So that ends up being 30x equals 180. Divide both sides by 30, and x is 6. So if x is 6, I go back to find AOD. That's 25 times 6, which is 150 degrees. Okay, so this right here is 150 degrees. So what if I wanted to find AOE, which is this angle right here? To subtract 150 from 180, because again I have another diameter, right? So these two added together is going to be 180. So 180 minus 150 is going to make AOE 30 degrees. Okay, now the next thing we want to talk about is what an arc is. And an arc is part of the circle, okay? Defined by two endpoints. So this right here is an arc. It goes from one point to another. That's an arc, okay? An arc is measured in degrees, just like angles are measured in degrees. And all the degrees of an arc equals 360. Just like if you were to add up all the central angles, it equals 360. All the arcs does, and you'll see why here in just a second. A minor arc is an arc that's less than 180 degrees, less than a semicircle. So this right here is considered a minor arc, okay? When you name a minor arc, you use the two endpoints, okay? So this would be arc AC. So you would use those two, and then you would put a little mini arc on top of it, okay?
Oh, that's AC.
I know, my board is acting weird. I know. Well, I write it and it like puts it over to the left for me, so I don't know what the deal is. I fixed it a while ago. Maybe somebody hit it again. Let me try and see if that'll help. Okay, maybe that'll help. All right. So this right here is arc AC. Now, the measure of an arc is always equal to the measure of the central angle. So if the central angle is 110, the arc is going to measure 110. Okay, so the measure of the arc is equal to the measure of the central angle, and your arcs again are measured in degrees. Okay, now that's a minor arc, less than 180. A major arc is greater than 180. It's bigger than half a circle. Okay, so this right here is a major arc. Okay, and I wouldn't want to name it arc DE because you would think I was talking about this little bitty one. So when you have a major arc, you have to use a third point, which gives it direction. Okay, so you would name it arc DFE. Oops, let's see. DFE, or you could go the other direction and name it EFD. Okay, so that's how you name a major arc. That you have to give it that third letter in the middle to tell you which direction to go. Okay, now the measure of a major arc is basically what's left of the circle from the minor arc. Okay, so if the minor arc is 60, then this is 60. This is the rest of the circle, which is 360 minus 60. So this particular one is 300 degrees. So you just take the minor arc, subtract it from 360, and that's what your major arc measures. Okay, and then we have the semicircle. Okay, the semicircle is half the circle. So if the whole circle is 360 degrees, the semicircle is half that, which is 180. Okay, and again, just like with the major arc, you have to use three letters. Because if I said arc JL, you would know if I was talking about this one or this one. They measure the same, but if I am identifying it, I need to know which one you're talking about. So the blue one, you would state it as JKL, and then the red one would be JML. And then your semicircle always measures 180 degrees, no matter which one you're talking about. All right, so your minor is less than 180, your major is greater than 180, and your semicircle is 180. Okay, then we have adjacent arcs. Remember we talked about adjacent angles early on in the year, and those were neighbors. They were right next door to each other. All they did was share a ray, okay? Well, your adjacent arcs share a point. That's it. So if you were talking about point ray PQ, arc PQ and arc QR, those would be considered adjacent arcs. And the only thing that they share is that point they have in common. They're right next to each other. We have the arc addition postulate, just like we have the angle addition postulate and the segment addition postulate. And basically all it's saying is you add one arc and its adjacent arc, it's equal to the whole arc. Okay? And when you talk about the measure of an arc, you put a little m in front of it. So the measure of arc PQ plus the measure of arc QR equals the measure of the entire arc, which would be PQR. So if PQ was, let's say, 60, and QR was 150, then the whole arc would be 210. Okay, so that's the arc addition postulate. Okay, in circle F, the measure of angle DFA is 50. We have it labeled. CF is perpendicular to FB. That means they form a right angle. We want to find each measure. Okay, so the first thing I want to find is the measure of arc BE. What's the measure of arc BE going to be? 50. We've got vertical angles here, so this is 50. And remember, the central angle and its arc are equal. So that's going to be 50 degrees. Okay, how about CBE? Well, this is 90, right? And this is 50. So yes, 90 plus 50 equals 140. Good. Okay. What about a CE? 230. What did you do? Okay. So he recognized that these are both right angles, or you could think of this as a diameter. So that's 180 and then plus 50, right? So 180 plus 50, which we said was 230 degrees. The other thing you could have done is we already knew that this was 140, right? And this just added on another 90. So you could have done 140 plus 90. You know, however you do it, either way it works. Okay. Now, this is kind of, when you talk about this, if you had to create your own circle graph, this is what you would have to do, okay? This graph shows the percent of each type of bicycle sold in the United States in 2001. Find the measurement of the central angle representing each category. Okay, so in 2001, this is kind of old data, but in 2001, 37% of the bikes were mountain bikes. Okay, 26 were youth bikes, comfort was 21%, and so forth. Okay, we created this, graph, but what if you had to do it by hand? Okay, what is this 37% of whenever creating the pie chart? Well, it is 37% of 100, right? But 37, but of the chart, it's 37% of 360 degrees, right? Because if I were going to create this central angle, I would need to know how many degrees it was in my pie chart, right? So you have to take 37% of the whole circle, which is 360 degrees, okay? Which we did this one right here. So 37% of 360. And when you find the percent of a number, there's like 3 different ways that you can do it. I like to just change the percent to a decimal. I remember Dr. Pepper, percent to decimal. You go 2 places to the left. So that's 0.37 times 360, because of means times. Some people like to do is over of equals percent over 100. So you were right when you said 37% out of 100. So you could do 37 over 100 equals x over 360. If you like to do it like that, that's fine. Some people, they like to move the decimal on this and do 37 times 3.6. Okay? 3 ways you can do it, whatever you're more comfortable with. Okay? But this is probably how I will do it. But like I said, the 3 different ways that you can do it. All right. So what is 37% of 360? 133. Okay. So that's 133 degrees. Okay? The hybrid is 9%. So I would change that to a decimal, 0.09 times 360. It's 0.09 times 360. .4, so about 32 degrees. And then the comfort is 21%, so that's 0.21 times 360. And that's 75.6, so 76 degrees. Okay. So, pretend like we don't have the Excel spreadsheet or the sheets to make our own pie graphs for us. We had to do it on our own, right? How would we do it? Okay. All right. Now, the last thing we want to talk about, an important thing, you will have it on a test or a quiz, both probably, but something that people tend to forget. It's not hard, they just forget. And it talks about arc length. Okay, and that is the length of part of a circle. We talked yesterday about what circumference was, right? And that's, the distance all the way around in like centimeters, meters, whatever, okay? But arc length is just like from here to here, okay? Your arcs have measures in degrees, but they also have lengths, which is in centimeters, meters, feet, miles, whatever, okay? If we go back to this, remember we said every time it clicks, it's 1 rotation, right? But if you don't go all the way to a click, then it's part of it, right? That's arc length. That's how long it is, and this would be in centimeters, okay? So that's what arc length is. And so to find arc length, you have to take the length of the arc over the circumference, because it is part of the circumference, okay? It's a portion of it, not the whole thing. And then you take the measure of the arc out of 360, which is the whole circle. So this proportion is part of the circumference over the whole circumference, part of the degrees over the circle of the whole circle, okay? So part to whole, part to whole. That's how you do it, okay? All right, so in this example here, it says you have circle P. It says that PR is 15 and the measure of angle QPR is 120. We want the length, okay? Now, what's the measure of the arc? 120. The measure of the arc is 120 degrees. We want the length of it, okay? So to find the length, we take the length, which we don't know, out of the circumference. What's the circumference? 30 times pi, because the radius is 15, which means the diameter is 30 times pi, right? So that would be 30 pi. And then we take the measure of the arc, which is 120 degrees, out of the entire circle, which is 360. Okay? So The arc length is to the circumference. The measure of the arc is to 360. Part to whole, part to whole. Okay? So we cross multiply and we get 360x equals 3600 pi. We divide both sides by 360. And if it wanted an exact answer, it would be 10 pi. And it could ask for an exact answer. That would mean you'd have to reduce that fraction sometimes. Okay, if it wanted an estimation, let's say to the nearest tenth, that would be 31.4. And it didn't give us a unit of measure, did it? Okay. So that is arc length. That's a portion of the circumference. That's how long part of the circle is, not the entire circle. So part to whole, part to whole. Okay, the last thing we want to talk about, and these are basically just two definitions. I don't know if we might come back towards the end of the year and go and talk about how to find the measure of the sector of a circle and the segment of a circle, but I want to tell you what they are, okay? A sector of the circle is the region bounded by two radii in the intercepted arc. It's basically the pi piece, okay? This right here is called a sector, okay? It is not a triangle. One year, we did a project, and I had them go take a picture of an equilateral triangle or an isosceles triangle, okay? That's not an isosceles triangle. Why not? It's got a curved part, doesn't it? Okay, this is called a sector. It is like a pi piece of a circle, okay? All right, then if you take that sector and you connect with a chord the two radii, this little piece that's left up here, that segment right here, and the arc part is called the segment of a circle. Okay, this is a segment of a circle. And basically you take the sector and you cut the curved part off from radius to radius. You draw a chord, and that part that's left is called a segment. Okay? So sector, segment. This is an arc. This is a sector. These are both radii. This is a sector. This is a segment. Okay? All right. Any questions?